Hello, everyone. Welcome to the GSE UK Conference 2021. This is session 2AV, where we have Stefan Raspel, who will talk from IBM, who will talk about Linux on IBM Z and what's new. Over to you, Stefan.
Thanks a lot. So my name is Stefan Raspel. I work for IBM Germany Research and Development in Böblingen. And I'm the product owner for Linux on IBM Z.io. And today I'm going to show you around on what's the latest in Linux on IBM Z and Linux One regarding both base Linux and KVM. One question up front, because I had some technical issues. How long do I have time? When should I be done with the session?
I'm sorry, you have an hour, and I'll
an hour. Okay.
I'll prompt you when we get a bit close.
Great, awesome, thank you. So let's get started after we've had a brief look at the charity raffle. What's our agenda for today? Well, we have three major segments here. One is about the Linux on C distributions. This is going to tell you how to get Linux on IBM Z in the first place, what's the ins and outs about the different distributions, what's your options here, and also support timeframes. More on that in a minute. After that, we take a look at all of the latest Z features, and I'm also going to highlight some of the packages we're supporting, either by just making them available on the platform or by providing them in the first place. And finally, we take a look towards KVM and what's going on in that area. So let's start right away. First topic, Linux on Z distributions. So first off, and this is a terribly important chart, in case you're already running Linux on IBM Z, because this chart depicts which Linux on C distribution supports what hardware level. So on the horizontal header here at the top, you see all of our IBM Z releases dating back to the C196, which was quite a while ago. And in the rows, we have all of the different Linux distributions dating back to some like Red Hat 5, which isn't even in service anymore, but listed still. And the purpose of this table is really, before you're updating your hardware, you should consult this to figure out if a Linux distribution is really running on your new piece of hardware. Because sometimes we use something called an architecture level set, where binaries are compiled using the instructions of the very latest available hardware. And, well, not necessarily the very latest available, but some later level of hardware. And therefore, they might not run anymore. That's something which, for instance, happened with SLES 11. That was unsupported with the C15, sorry, my confusion. SUSE did not formally support it on C15. We didn't introduce the required patches. But what can also happen is that a certain Linux distribution, for instance, doesn't run on an older piece of hardware anymore. That can happen, right? So Red Hat 8 would be a respective example that was optimized for C13 or later, so it won't run on a C12 anymore. And that's also part of the charm of this table. So this table is getting updated all the time. There's a link at the bottom of this page where you can always get the very latest version here. But let's move on and take a look at individual distributions. So the first one to check out is SUSE Enterprise Linux. And their current release is SUSE Linux Enterprise Server 15, released initially in 2018. And for each of these releases, I've given you the regular support time frame. And that's the same thing with pretty much every distribution out there. You can always get some service contract extension, and usually purchasable. And that gives you a couple more years to run the respective distribution. Now, since SLES 15 came out just 3 years ago, it's still got an awful lot of life left in it. So that's good till 2028. And you can get 3 more years in case you're purchasing a respective service extension. SUSE has an interesting service model insofar as they're switching their Linux kernels entirely every 2 releases. So the GA version of /15 came out with kernel 4.12. The first service pack continued to do so, but the second service pack already switched to kernel 5.3, and that's what they also kept for the third service pack. And you can assume that the fourth service pack will do another kernel upgrade. Now, what does it do for you in case SUSE upgrades a kernel? Well, that means that you get all of the latest Linux community's developments, both major and minor features. And that's all, of course, pretty cool for us in development, because that saves us the trouble of doing any tedious spec ports for some of the features which come in through the kernel update level, but also gives you the opportunity to check out some of the minor features which the Linux community out there might have contributed. So it certainly refreshes your Linux distribution, if you will, to a certain extent. SUSE still has 2 other distributions out there in service, which would be /11 and /12. Both follow the very same scheme, and I've listed all of the respective kernel levels and so on and so forth in here, as well as the support timeframes. In case you're still running /11, it's about time to figure out a migration strategy, because the regular support time frame ran out March 2019, which is quite some time ago. And in less than half a year, that distribution wouldn't even be supported anymore, even if you had purchased a service extension. So that's something to definitely be aware of. Otherwise, and this is something we start to stress just lately a little bit more, here on the lower left, please don't forget to keep your Linux distribution current. And this does not relate towards switching towards later service packs. This is towards running the, I might say, daily updates, where you have a constant stream of updates from the Linux distributor. SUSE calls those main web updates, and they give you all of the minor fixes for existing applications, as well as security updates, of course. But our main concern here, and not to downplay security aspects really, but our main concern here is just getting the odd bug fix, because we had a couple of instances, especially lately, where customers were running into issues. They opened a service ticket with us, and it turns out after some debugging that this has already been fixed in the main web updates, which were already available to customers. And this is not so much about that causing us a lot of work. It's more about your inconvenience. So that's why we would definitely recommend to always make sure you're running the very latest main web updates for SUSE. So let's move on to Red Hat Enterprise Linux. Likewise to SUSE, Red Hat has 3 releases in service currently. The very latest one is Enterprise Linux 8, which came out in 2019. Ever since that happened, or ever since the first service update, they have been on a 6-month release schedule, or update cadence, if you will. So in May this year, Red Hat Enterprise Linux 8 was released, 8.4. And from that, you can figure that sometime in November, the next Red Hat update is likely going to be released. Of course, they might diverge here and there from the schedule. It's all software development after all, but you can expect sometime in November for an update to happen. Red Hat did not yet give a deadline or a time frame for the extended service, which you can purchase for them. So far, all we know is in 2029, the regular service time frame ends. And how long after that, we don't know how long you can prolong that with service contract. Red Enterprise Linux 7 and 6 are also available. And yeah, that's something I should also mention. Red Hat sticks with this particular kernel level. That's why there's now no further kernel update level printed here for any of the service releases. Red Enterprise Linux 6 started with kernel 2.6.32. And they just kept it for the entire life of that distribution. Likewise with Red Enterprise Linux 7 and now Red Hat Enterprise Linux 8. However, don't be fooled by that. Red Hat does an awful lot of backports. So whenever they feel some development in the Linux distribution is worthwhile, they backport it to their code base. So the kernel level version number to a certain extent becomes sort of meaningless at later stages of the distribution's lifetime. So that's something to be aware of. Of course, the primary goal of that is to provide a distribution which has tremendous stability. So that's certainly something, some interesting aspect of that. Likewise to what we saw with SUSE, their oldest release, which would be Red Enterprise Linux 6, is already out of a regular service time frame. And however, that still has quite some life left in it. So it's in case you have a service contract, you can still run it to 2024, which is quite a way to go. And again, just like with SUSE, they have a constant stream of bug fixes and security updates. And likewise, we would definitely urge you to consider applying those whenever they become available. It's called CStream updates for Red Hat Enterprise Linux. And again, you can save yourself a lot of trouble if you do so. Now, finally, and this is in terms of its update cadence, the odd guy, if you will, Canonical's Ubuntu. So they have a different update model, which is quite interesting. They have a release cadence of 6 months, and every 2 years, they release what they call a so-called long-term support release. And that LTS release is supported for 5 years, and after that, you can purchase another 5 years worth of support. And that's certainly good enough for any enterprise customer, we assume. However, the releases in between, which are not LTS releases, like, for instance, the very latest one, which was this Ubuntu 21.10, they are only really supported for 9 months, and then you have to switch over to the next non-LTS release. And that's something which we felt is probably not really so great for typical customers, typical enterprise customers, because they are, from our experience, rather reluctant to switch their distribution levels all the time. So they want more stability and have their releases tested out very well with their individual software applications. So we assume that most of our customers typically will stick with the LTS releases. So far, Canonical has released 3 applicable LTS releases, and that would be the 1604, 1804, and 2004. As you can see, the 1604 has a little bit of a different service time extension, because that runs till 2024. So it isn't extended by 5 years, but only by 3 years. But otherwise, the 5-year thing holds true, as I mentioned before. And again, Canonical has its own stream of updates. They call it SRU updates. And just like with any other Linux distributions, please make sure to apply those. Now, related to the Linux distributions and also related to the support matrix I showed you initially, in case you're looking for C15 toleration support in particular, this chart might be of interest to you because this now details which exact service levels you require to run on a C15. Because the support matrix, which I showed earlier, just depicted the major Linux releases, not the service levels. So for instance, it would tell you that Enterprise Linux 7 is supported on C15, but not that in particular you need 7.7 and with a C-stream update. So this is a chart to go to for that kind of information. And you should definitely consult it prior to migrating to a C15 in case you're contemplating to switch over any workloads. So far for Linux distributions. Now let's take a look at the actual features which we're providing. So we're going to discuss features which are either already available in distros, but not for a long time yet, or features which are just coming up and might in some cases only have made their debut upstream so far. So let's start right away. First one would be deflate support. Now this is a feature in our IBM C15 hardware, which we're pretty proud of, because what we did here is we implemented the gzip algorithm for compression and also for uncompression for that matter, completely in hardware. It's becoming available as a hardware instruction, and that's got to be terribly fast. And it is. There's some benchmarks here on the right-hand side, and as you can see, we achieved something in between 24 times the performance up to 42 times the performance of doing the same compression of these respective publicly available test files with our deflate algorithm as opposed to doing it in software. So that's really huge numbers, really. What we provide is compression level 1, which is in software already the fastest level, but we made it a lot faster. And in our initial release, which is what I printed here on the upper right-hand side. So as you can see, Ubuntu 19.10 had that, Red Hat 8.1, and /12 SP5 and 15 SP1. They had that functionality, but per default, you wouldn't use it because gzip defaults to its compression level of 6. And remember, our deflate algorithm is only providing compression level 1. But we changed that after a while. So with Red Hat Enterprise Linux 8.4 /15 SP3 and Ubuntu 2010, we enabled it per default in all of these Linux distributions. So whenever you are running gzip or your application uses a C library or a Java application does some compression, or you're running, gzip I already mentioned, or you're running compression in any other application, you would per default now start to use our compression in hardware. If that's not good enough for you, or if you want more fine-grained controls, that is possible. So there's some environment variables depicted here at the bottom, which you can set, where you can tune exactly at which compression levels you want to take advantage of hardware compression support. Otherwise, there's an excellent article linked here at the bottom, which goes to more details on how to enable or disable the support in which distribution exactly. Now, next up is CPAC-F. That's our crypto support. We had an update of CPAC-F, of the CPAC-F instruction in pretty much every new processor generation for a couple of IBM Z generations now. And again, it's just about providing great performance. So we're tremendously speeding up the encryption and decryption performance, while at the same time, this does, of course, also save CPU cycles. The very latest version of CPAC-F is called the Message Security Assist MSA9 and focuses in particular on elliptic curve cryptography. And what we do is we provide acceleration for message authentication, elliptic curve key generation, and also scalar multiplication, which is an operation required to decrypt and encrypt using ECC or elliptic curve cryptography. It can be used with SSL and TLS protocols, so OpenSSL support is available, and we have a couple of, a whole array of curves supported listed here on the right-hand side, and again, the performance numbers are really cool. So we have like 20 times faster key exchange operations, 38 times faster sign operations, or 10 times faster verify operations. So that's certainly pretty impressive numbers. So moving on towards more storage-related topics, the first one would be secure boot for SCSI IPL. Now, this is probably one of the oldest features, but in this presentation today, but still finds a lot of friends. So what it does is it makes sure that when you're loading or IPLing, as we say on the C, a Linux instance, that the kernel you're running is actually really provided by the respective distributor, which would be either Red Hat, SUSE, or Canonical. So that's the three Linux distributions where the distributors basically sign their kernel images, and we are verifying that these signatures actually are valid. And if they are not, we're refusing to boot. So what you need to do is you need to enable this feature, because per default it is turned off. And you can have a switch in HMC that turns it on. And when that happens, the verification happens, as I mentioned before. So the whole purpose of this is really increasing the security, so you're not running risk of booting a kernel image that somebody tampered with. In case you're enabling this feature and you're wondering whether it's actually active, there's respective Sisyphus attributes listed here on the right-hand side on the top. And of course, you can use SIPL to trigger whether you want to enable or disable it, and what kind of support level you want to have here running. So next up in storage would be NVMe devices. And again, this is something we continue to talk about because this is a feature which is only available for Linux One. So it's not available for regular enterprise IBM C15 machines or single rack models, if you will. It's really just reserved for Linux One model, either the Linux One 3 or the Linux One third generation single rack model. And what we provide is actually not, and this is also something new, we're not providing the actual disk, but rather a carrier card or adapter card, where you can bring your own NVMe devices and insert it, and then plug it into our I/O drawer. Now, NVMe devices, as you probably know, provide very cost-effective storage solutions, very low latency, very high throughput, and for the first time, you can have storage inside our IBM C box, which is something which previously was not possible. So here you can, for the first time, or could, run an IBM C Linux instance where you're booting from local storage as opposed to booting from some remote storage, your DS8K or whatever you have. So that might create some interesting scenarios for your application deployments. If you wonder how to operate that, well, After all, it's a PCI device, and that also has its charm because it means it's just operating like it would on x86, for instance. It's not like some other of our storage pieces, like, for instance, DASDs, where you have special commands because it's just a CCW device. No, this just shows up as a regular PCI device, which means LSPCI will list it. Commands like lsblk will list it gladly. And all that's left to be done is just partition the respective disk and mount it somewhere, format it, and that's pretty much about it. If you want to just store data on it, the service levels which I mentioned before or were printed on the previous page apply, all no problem. So you could use it, for instance, to speed up your swap storage or add it as a data disk inside Linux for workloads which are very I/O sensitive. If you want to also boot from it, that requires what we call IPL support. So that's printed here on the right-hand side at the bottom. IPL support came a little bit later only, so that's available in Red 8.3/15SP3 or Ubuntu 20.04. So we are a little bit stricter in terms of required Linux distribution support here. Other than that, the experience should be pretty flawless, especially since we have Linux distribution installer support available for that. So that should give you a very smooth installation experience. Okay, moving on. CDSFS now is a feature which has been around for a while, but we never really talked so much about it. And it turns out there's a lot of folks out there who have a good use case for that and might have not been aware of this. So that's why we talk about it here. This is interesting for co-location. So imagine you have a COS LPAR, as depicted here on the left side, and a Linux instance on the right side. And a lot of our client architectures have COS store the data, and Linux is then used for instance, for generating reports or running statistics on it or doing some kind of processing of the data, which means you need to process the data. You need to get to the data in the first place with Linux. And traditionally, what a lot of our users are left to do is they set up an FTP server on COS and they download the data in Linux, store it locally, and then start processing it, which is, for one, sort of ineffective because you have to transmit all of the data first and from COS to Linux. And it also certainly burns a lot of CPU cycles on COS, which COS customers really don't like so much. So wouldn't it be great if we could just access the data from the DASD that COS uses to store the data on right away? And that's what CDSFS actually does. So it's a file system implemented as a user space file system, actually. And in Linux, you can then mount that respective DASD volume and access the data easily. That's depicted here on the lower right in this little box. This is a complete usage example where you're first off using CDSFS to mount the disk at some arbitrary mounting point here. And then you can do something with the data on the disk, like reading it out through this command or whatever you want to do. And finally, you can unmount the disk again, and that's about it. We are continuously investing in that technology. So we had a couple of updates to it. First off, we worked on the robustness quite a bit before we introduced coordinated read access. So you didn't any longer have to set the device offline in COS while Linux was accessing it. And the very latest feature that we added is transparent dataset conversion, because COS usually stores its text files in ABCDIC. And when you're accessing it from Linux, you would have to perform a code page conversion. And we can automate that. So you can configure which files, for instance, based on a scheme. So you could, for instance, if that's your convention, say, okay, any file with a TXT extension on that disk should be automatically converted from ABCDIC to ASCII. That certainly makes it very, very convenient. So this might be very interesting for folks who are running such a co-location case with COS. So on to the next technology, which would be SMCD version 2. This came out just a couple of months before. Now, if you're not familiar with SMCD to begin with, that stands for Shared Memory Communication Direct, which means we have two LPARs on the same CPC, obviously. And what we do is we assign so-called ISM or internal shared memory devices to each LPAR. And we can then run the TCP data over these ISM devices. And these ISM devices are terribly fast, so you can reach tremendous throughput and latency values with this technology. It's hugely impressive what kind of throughputs you can achieve with that. However, the technology initially in SMCD version 1 had some limitations. Two of them mainly, which are addressed now here. One limitation was that the peers had to be in the very same IP subnet. So as soon as a router was involved, like here in this diagram, you know, here's a router here on the left-hand side, and LPAR2 also accesses a router somewhere on the way to the firewall that might be in between. We could not support that initially, and this has been lifted with SMCD version 2. So with SMCD version 2, it really does not matter anymore what the networking topology between the two peers is, as long as they have any means to communicate with each other. It doesn't matter how many, it doesn't matter how many layers of routers are in between, what your networking topology is. None of that matters anymore. As soon as they can communicate with each other, they are fair game for SMCD version 2 enablement. Another area where we greatly improved SMCD in the second release is configuration. Now, previously, you had to fumble with something called PNet IDs, which is a concept where you're basically assigning some attributes to your NIC and then the same value to your ISM device. So the two would be logically paired. So you knew that if you have some traffic which routes through, or which Linux sends out through that NIC, then that traffic would be eligible to go through this ISM device up here, especially in case you have multiple NICs or multiple ISM devices. And we just did away with that altogether. So we eliminated PNet IDs entirely. So all you do with SMCD version 2 is you just add an ISM device and you're not configuring it anymore. You're not assigning PNet IDs. You're not doing anything further. It just needs to exist, and that's the end of the story, which is, from my point of view, a very big achievement in terms of usability here. SMCD version 2 requires a C15 or Linux 1.3 model. So that's because the ISM devices required a small change. But other than that, it's available in Linux distributions as depicted on the upper right. And in case you're wondering, there's also SMCR out there, and that shares the same restriction as SMCD version 2 does in terms of both peers are required to be in the same IP subnet. And that is also getting an update. I don't have a slide in, what do I have a slide in my presentation? No, I don't yet, because it's just so new. SMCR version 2 is coming. The code went just upstream a couple of weeks ago. That's why it's just too new to really talk about this yet, but we'll soon start talking about it. And that will also lift the same IP subnet restriction for SMCR. However, we're remaining with the PNet ID configuration option there, just as some kind of outlook here. Okay, speaking of SMCR, now, as I mentioned before, SMCR is basically the twin of SMCD. It stands for Shared Memory Communications Remote. And that means you have two IBM Z CPCs, which are interconnected by RoC Express adapters. And these RoC Express adapters are used for, again, for transmitting TCP traffic using RDMA, which is, again, terribly fast. And one thing which we didn't support before with SMCR was link groups, which is essentially failover support. So you can now, in Linux, have multiple RoC Express adapters, 2 of them to be exact here. And in case one of those RoC Express adapters has an outage for whatever reason, maybe it's a cable pull or device failure, doesn't matter, the traffic fails over transparently to the remaining RoC Express adapter, and that continues to operate. And when the other adapter, the faulty one, comes back up or is replaced and added back to, and then a replacement added back to the system, we can start using it again. So your applications continue to run without ever missing a beat. That support has been around with COS for a while. With Linux, it did not yet, but that's the gap we're basically closing here. Now, of course, and I didn't mention this for SMCD version 2 before, all of our SMC technology is compatible to COS for 100%. So whether it's SMCD version 2 or version 1 or SMCR or the forthcoming SMCR version 2, it will always, we're making sure that it's always running quite perfectly with COS in particular. Now, let's move on a little bit, but remain with networking technology. Here's what we call hypersockets converged interface. Now, this is a technology which tries to address the problem, a common problem when deploying hypersockets in your systems, because previously, what you had to do is, when you're deploying hypersockets, you had to put them in their own IP subnet, which obviously has an impact to your networking topology. And that's something which a lot of our users really didn't like so much because they want to keep their networking topology as simple as possible. And while hypersockets provide a great benefit by providing very low latency connections, having an extra IP subnet is a little bit of a burden to a lot of our users. So the concept of hypersockets converged interface is that you're adding next to your regular NIC, which you always need for external connectivity, you're adding a hypersockets interface, and you're then defining a virtual hypersockets converged interface, which is then the sole interface carrying an IP address. So you're getting back to a model where you have to deal with only a single interface inside Linux that has to be configured for IP connectivity. And the HSCI interface under the covers switches all traffic that can be sent internally to a peer, like in this example, to the COS guy over here. That traffic is sent out through hypersockets because we can detect whether the receiving end is on the same CAC or not, or same CPC or not. And any other traffic defaults to getting pushed out by the NIC. So in essence, we're using hypersockets whenever we can, and whenever we know that the receiving end is on the same box. And in all other cases, we're sending out the traffic through the regular NIC, and everything is okay. Now, this support so far is restricted insofar as that we currently can only register a single MAC per HSCI interface, but that is again going to be lifted. This was our first release depicted here, as depicted up here in these distribution levels, but we just submitted our patches and they were accepted upstream by the Linux community, especially a couple of weeks ago. The support for multiple MAC addresses is coming, and the impact of that is, with the current implementation, you could not add an HSCI interface towards something which needs to register multiple MAC addresses, like, for instance, an open vSwitch, as often used with KVM, or make VTAP, again, as often used with KVM deployment scenarios. And with the forthcoming, as we call it, multi-MAC support, this restriction is lifted, and you can then move your HSCI interface towards whatever Linux virtual networking framework you want, like Mac VTAP or Open vSwitch again. Now, hypersockets converged interface requires a C15 or a Linux 1.3, so there's quite a bit of hardware support required here. If you are using hypersockets converged interface, all of your peers also have to use it. That's one caveat to be aware of. So if Linux uses it, this Linux one guy over here cannot just tap into the hypersockets. It would have to go all the way and also configure an HSCI. That's something to be aware of. This support is available for LPARs. In CVM, there's the excellent vSwitch, which provides something called Bridgeport support. If you look up in the manuals, you will easily find it. And that is essentially providing the same functionality. That's why we're not making this support available in CVM guests. On that, there's a small example down here on the lower right to illustrate how to set this up, which should be quite easy. And let's move on. And this last and final networking topic. For Rocky Express, we're introducing a new naming scheme. Now, one of the best kept secrets in IBM Z is probably the fact that you can run Linux with a Rocky Express adapter as a native TCP/IP interface card. However, one of the not so great aspects previously was that the interface name could vary drastically. And here on the right-hand side of this box, there's just a subset of what the naming scheme might have looked like for you. And it's pretty much, in essence, unpredictable, which is your interface name in case I told you what your FIT and your UID is. That was not such a great story, really. It wasn't even all our fault. Part of that is, for instance, system debugs that played a role, as well as some other factors. Now, we're introducing a new scheme, which is pretty simple. So starting with Linux kernel 5.13 and systemd version 249, in case you have unique UIDs enabled, and that's what we strictly recommend to anybody running with Rocky Express adapters, your interface name will be in this will follow this convention where you're just using the UID in decimal. If you do not have unique UIDs enabled, if they are disabled, you will have this convention here where we're replacing the UID with the FID again in decimal. Now, why is this important? This is especially important in case you're trying to install a new Linux instance and you need to know upfront what your interface name will be in case you're installing first Linux on a box which does not carry any networking card other than Rocky Express adapters. So that's where this becomes really important. Right, and also let me point out that previously we didn't really talk so much about Rocky Express. We start to compare them a little bit, but we're now at a point where we see that a lot of our customers are seeing a lot of benefit in the Rocky Express adapters because they have very low latency, great throughput characteristics. So they do a lot of good things for a lot of our clients. And that's why we're increasingly talking about them. The story is not yet complete. I will be back with a new separate presentation on Rocky Express adapters specifically next year. And there are still some gaps to close, and we're working on them one by one, but we're committed to doing so. And this is one piece of that. So stay tuned. Now we're pretty much at the end of the new features for regular Linux. So let me go quickly over other packages that we're providing. You might be aware of our S390 tools package that's getting continuously updated. Some of the latest features we have, and one of the highlights was that we're now auto-activating PCI devices and crypto devices under DPM. Previously, you had to activate them manually for first time when you were running under DPM, and that was quite tedious, but we fixed that. So now they're getting auto-activated, which should be a great usability improvement. OpenCryptoKey is continuously receiving updates, most recently support for OpenSSL version 3. QClib, the latest version has been out for a while. And prior to that, we had a version which introduced 2 end-user commands, which I guess not so many folks are aware of, but might come handy, very handy. So you might just install that package and give it a spin, because one tells you exactly what the name of what version of an IBM C you're running in clear text, and the other one is detailing you in a comprehensible manner, hopefully, what your virtualization layout looks like. So in this instance, in this example, for instance, you're seeing that you're running inside a CVM guest, and that might not be obvious to you in case you're just logging on through a terminal to your IBM Z box, and might be oblivious towards what's really going on under the covers. And finally, there's of course the SMC tools, which get constant updates. Most recently, statistics on SMC usage. Compiler-wise, we're continuing to focus on GCC and LLVM, and IBM Z15 support is readily available for quite some time now. So it's just to reassure you that we continue to invest in both of these compilers, just in case you were wondering. As far as libraries and debuggers are concerned, and again, this is more for a development crowd. Of course, obviously, we have to support the GNU C library, and the GNU debugger is another mainstay which continuously gets updates. Valgrind, which is a pretty cool memory debugger, finally received support for the C15. It's something which was taking a little bit of time, but now it's here. For end users, it's not really so much of a big deal because most Linux distributions, or none of the major Linux distributions out there, use the C15 instruction set yet. But for the rest, if you're building your own and optimizing for C15 instructions, this might have been something you were missing. So the support is here. And finally, there's also Perf Toolkit, which we continue to support and also has C15 support readily available for a while now. Now, as far as libraries with IBM Z optimizations are concerned, there are a whole bunch now. There's a couple of algebra libraries which implement the BLAS framework.
9 minutes left, Stefan.
Yep, thank you. So it would be OpenBLAS and libatlas. We updated the eigen package with support for specific IBM C instructions dating up to alignment hints in C15. Anaconda is a pretty popular data science platform, which we brought to the mainframe, to Linux on the mainframe. And finally, and this is really brand new, the IBM Z Deep Neural Networking Library is already available out there on GitHub, and it provides support for the neural network functionality in the forthcoming IBM Z processor. So finally, over to KVM. Now, here's a list of what's currently available, what distributions. And of course, what to look for is the kernel level. But as I told you before, especially with Red Hat, this is might be misleading a bit, as even more so as we do our own backports for it. QEMU is always important, and libvirt, because both of these packages provide a whole lot of functionalities which you might be interested in. And I'm happy to say that all three major Linux distributions continuously update these packages. So KVM support should be pretty good for you in any of the big three. Now, how to install KVM? Here's a nifty list of one-liners. So that should get you started really quick. And once you have installed the required packages using any of these commands, all that's left to be done is defining your own guests using the XML configuration files. And there you go. Now, as far as features are concerned, I pretty much covered all of these features before for regular Linux. These are all C15 features. I didn't talk about the new vector instructions so much anymore. They are getting used automatically and used automatically by the compilers. But otherwise, deflate, we talked about CPEC-F and secure execution, and never mind the miscellaneous instructions. You probably won't care for those so much. We do, but you probably don't. So these C15 features are readily available in KVM, all of them. However, that means you need to make sure you choose the right CPU model. And for one, we made sure there is a CPU model for the C15 available to begin with. And if you're looking into the respective mode, and this is what this chart is really all about, make sure you pick the right one, because we strictly recommend to use a host model, because we feel that's the best compromise between stability and think about live guest migration issues with that, and feature completeness. Now let's take a look at actual new features for KVM, and our main feature here is really secure execution. Now, what does that do? Basically, when you're running a KVM guest, you're running your Linux LPAR on top of the Prism hypervisor. That's a hardware hypervisor in our machines. And the Linux LPAR, of course, runs a KVM kernel module, the QEMU user space process, which actually owns the guest memory or represents a guest to begin with. And there's now a couple of attack vectors possible. For one, somebody could be inside your Linux kernel, some evil attacker, and start to mess around with your guest memory. Or you could have another user ID root process, which starts to attack your guest memory. Likewise, there's guest states stored here in Prism. And again, that would be another attack vector. And what secure execution does is it's basically protecting all of these, both the guest memory and the guest state, which is protected by something called an ultravisor. And any of these attack vectors would be depleted by that. That's the basic idea, really. So what it does basically is it's secure execution is locking up your guests so much as that you can actually claim that you have no way, even as a host administrator of a KVM instance, to look inside or tamper with the Linux guest running on top of you, which is certainly a first for us. So if you have any ultra sensitive workloads, this might be great. If you're looking at ways to ease your life in terms of compliance and certification, this might again be pretty good, because you can say, hey, look, I cannot even look into these guests. So I do not need to worry about the certification or compliance issues with KVM guests. You better talk to the guy who's running the actual guest, who's responsible to it. If you want to get started with secure execution, well, first off, you need to be aware it's an orderable feature when you're ordering a machine. It provides end-to-end memory protection, and that is controlled by firmware, of course. And we have a whole certified public key infrastructure in there, which builds a chain of trust. So you will have to actually create your own guest images, which have to be signed so they can run on secure execution. As a machine owner, you need to run any of these distribution levels as depicted here. As a workload owner, requirements for Linux distributions is a little bit relaxed, so you do not need as recent Linux levels. But that's what you need. Now, finally, and the final feature of this entire presentation, VirtualOFS is a nice shared file system, which can be quite handy to share data hosted in the KVM host among a multitude of guests. And here on the right-hand side, there's some code snippets of how to set all of that up. At the end of the day, it really boils down towards in the KVM host, you need to store all of your data in some arbitrary path, in some directory, and you're exporting it, if you will, towards the guest, so you can then mount it inside the guest. Very convenient, saves you the trouble of setting up some file server for sharing or some real shared file system, that kind of stuff. Very convenient. So with that, finally, let me just mention quickly that if you want to keep up to date, there's two blogs we're running. One would be for KVM on Z specifically, and the other one for Linux on Z and containers. So if you really want to be the first to know about the very latest upstream submissions and stuff like that, these are the places where to look for. Other than that, of course, we run our regular webcasts, which are available here, and we also have an awful lot of documentation out there. Especially video explainers might be interesting. They're very short, like usually running 2 or 3 minutes, but that's about it. And of course, IBM switched over to a new place for its documentation, so that received a huge rehaul, and you might want to overhaul, and you might want to check that out. With that, yeah, I'd be open for questions if you have any time. Otherwise, please submit your feedback for the session. And thanks so much for your attention. Okay, so we're done, right?
Okay, sorry, I was on mute. Thank you, everybody.
Okay.
Yeah, do you want to send me the slides, or do you want to upload the slides yourself to the GSE website?
I uploaded them this morning.
Oh, right, okay. Yeah, I probably haven't refreshed my screen, so that's fine.
If not, you just let me know. I don't know, but I uploaded them, so they should be readily available.
Okay, then. Thank you. Thank you a lot. I'll close the meeting now, ready for the next one. Okay,
Great.
thank you, Stefan.
Welcome. Bye-bye.
Bye.